Assalamu alaikum wa rahmatullah. Good day, everyone, and welcome back to problem 2. In problem 2, we will explain resonant frequency. As we can see written, problem 2 says, what do we mean by a resonant frequency in an AC circuit? Okay, in an AC circuit, we know that the frequency is variable. It changes, of course. Now, there is one particular frequency that we call resonant frequency. There are three fundamental principles associated with the resonant frequency, and I want you to pay attention to them. I will mention them one by one. Number one, at resonant frequency, maximum current flows through the circuit. I repeat, maximum current flows through the circuit. You cannot have any other frequency for which the current is greater than the current at resonant frequency. Point number two, there is minimum impedance. I repeat, there is minimum impedance. There is minimum impedance means that the total electric resistance in the circuit is minimum, is the least you can get. And this is why maximum current flows through, because the lesser the electrical resistance flowing in a circuit, the lesser the electrical resistance offered by a circuit, the greater the current flowing through the circuit. Minimum impedance, greater current. Point number three, this resonant frequency occurs when the inductive reactance equals the capacitive reactance. It means when the resistance offered by a capacitor is equal to the resistance offered by an inductor. Because the frequency is changing, the resistance of the capacitor and also the resistance of the inductor are both frequency dependent. If the frequency is changing, they are also changing. So when the frequency is at that resonant frequency, they are equal. Okay, they are equal, and because they are equal, you have minimum impedance, consequently maximum current flows through the circuit. So you remember these 3 points while explaining resonant frequency, and you give a statement that has all these 3 points: maximum current flowing through the circuit, minimum impedance, inductive reactance equals capacitive reactance. So with this, you can write your answer. We say solution. Okay, we say uh, a resonant frequency is a frequency of an AC, meaning alternating current circuit at which, meaning at this resonant frequency. Now you begin to mention the points. Number one, maximum, at which maximum current flows through the circuit. That is point number two. Point number two, there is a minimum impedance. And point number three, the inductive reactance equals the capacitive reactance. You see that? So we say a resonant frequency is a frequency of an AC circuit at which maximum current flows through the circuit, there is minimum impedance, and the inductive reactance equals the capacitive reactance. Okay, how do we get the formula for the resonant frequency? Okay, we use the last idea that says that the capacitive reactance or the inductive reactance X of L is equal to the capacitive reactance X sub C. See that? Now, what is the formula for inductive reactance? It is 2 pi FL, and the formula for capacitive reactance is 1 upon 2 pi FC. Now, when they are equal, we say the frequency is resonant frequency, and that resonant frequency is denoted by F naught or F sub R. So let me use F sub R, but in some books they use F naught. Okay, here I am maintaining F sub R. Okay, now make F sub R the subject of the formula. You simply multiply both sides by the denominator here to cancel fraction. So on this side I have 2 pi F sub R L. I will multiply this side by the denominator I have here 2 pi F sub R C, and then this is equal to what I have on the right hand side, 1 upon 2 pi F sub R C. Also, I multiply it by the same quantity, this one, 2 pi F sub R C. Okay, here now 2 times 2 gives 4, pi times pi gives pi square, F sub R times F sub R gives F sub R square, L times C gives LC, and this is equal to, okay, here 2 cancel 2, pi cancel pi, F sub R cancel F sub R, C cancel C, and you have 1. Next, you divide both sides by the coefficient of this F sub R square, which is 4 pi square LC. Here I divide this side by 4 pi LC. I divide this side by 4 pi square LC. Clearly 4 pi square cancels 4 pi square, L cancel L, C cancel C, and then I have here left F sub R with a square equals 1 upon 4 pi square LC. Moving on, I take the square root of both sides so that the square on the F sub R cancels, and I have only F sub R, and then I put the right hand side in a square root, 1 upon 4 pi square LC, and I end up with F sub R equals square root of 1 is 1 divided by square root of 4 is 2, square root of pi square is pi because the square root will cancel the square here. L and C, they do not have squares, so we maintain them inside the square root. This is the formula for calculating resonant frequency, as you can see. I hope it's clear to all of you, and thank you for listening and watching, of course. Assalamu alaikum wa rahmatullah.